Welcome back to the second video on Module 5. We're going to talk about sampling randomly. A simple random sample is one in which a sample of a certain size has an equally likely chance of being selected. Let's say I have a population of 100 people, and I want to take a sample of size 5. A simple random sample is one in which every possible sample of size 5 has an equally likely chance of being chosen. If I broke that sample into males and not males, and then I sampled in the males and I sampled in the not males, then I'm not going to get every possible combination of size 5 because I can't get 5 males. I can't get 5 not males because I'm taking some from each group. That's not a simple random sample. That would be a stratified sample, but a simple random sample is one in which every sample of that size 5 has an equally likely chance of being chosen. Common methods of simple random sampling is using a random number generator. Let's say you get your population and you use a random number generator to select whatever sample size you want. Putting every person's name on a hat, on a piece of paper and a hat, and drawing out from a hat. Using a table of random digits. Those are general methods you can use to create simple random samples. The goal of random sampling is to eliminate bias. That way we don't have people who are volunteering, or we're not choosing people with our own biases. So we're trying to eliminate bias by using random chance to decide who's in the sample. When we use that random chance, what happens to our variability? Why do we have variability in our sample results? We have variability not due to bias, we have variability due to chance. So when you use random selection, the variability that occurs in your sample, and variability meaning the differences that happens due to chance alone and not bias. And when you increase your sample size, the variability actually becomes smaller. So there's less variability in larger samples. You would think that more people, more variability. That's not true. As you increase your sample size, you are getting less variable and you're becoming more accurate. Later on, when we start to study variability, when we talk about standard deviation and variance, you'll learn how we calculate the variability for each population proportion or population mean, and sample proportion and sample mean, and why our variability actually decreases as your sample size increases. A census. Censuses used to be collected every 4 years, I believe, in the United States, and I think they're every 8 years now because they're so hard to do. So a census of the United States is when the government tries to get information from every single individual that's in the United States. And think about how hard that is. First of all, it's time consuming. It is very expensive, and it's very difficult because the population is not something that is just stagnant, doesn't just stay the same. People are dying and being born all the time. And so to be able to get an accurate picture of how many people live in the United States and what the average age is and what the average income is, all that information is very, very difficult. So a census is one in which every person in the population is included. So a sample where everybody is included. And if you have information on the population, we don't need to perform inference because you already have all of the information. So because a census is so difficult and so time consuming and so expensive to do, that's why we sample typically. We can't get information from everybody, so we use a sample to make inferences about the population. OLI does not talk about other types of sampling methods. They talk about simple random sampling, that's about it. But there are other types of sampling methods. There's stratified sampling, there is cluster sampling, there's multi-stage sampling, there's systematic sampling. A stratified sample is one in which you split the population into groups based on some similar characteristic, and then you do a simple random sample within each group or strata. For instance, if I had a population from a high school and I thought that age might impact my results, I could break the high school groups into freshmen, sophomores, juniors, and seniors, and then sample within each of those groups. Cluster sampling is where you take groups that are representative of the population. You have small clusters that are representative of the population, and then you simply random sample a few of those clusters and gather information from everyone in the entire cluster. Systematic sampling is where you use a random number generator to start at like the 7th person, and then you randomly sample every kth person, whatever k number you decide, every 50th, every 7th, every 100th. You're just systematically sampling in a row. Multi-stage sampling is where you can combine some of these different methods together. And I'm sure there are other types of sampling methods, but these are common ones that you might hear about. And lastly, can you infer cause and effect from an observation? No. No treatments are imposed. You cannot infer cause and effect from an observation. Okay, so I recommend that you head on over to Module 6 now to learn about experiments and get some definitions from that. And then when we move into Module 7, we will start using StatCrunch, and we'll start performing calculations about the center and the spread of data. Thanks for watching.